Hi, everyone. Welcome to the Reef Resilience Network webinar, Seagrass Conservation through Payment for Ecosystem Services. My name is Petra McGowan, and I'm the director of the Reef Resilience Network and one of your hosts today. I want to thank Gabriel Grimstitch from the United Nations Environment Program for co-hosting this webinar with us today. And before I hand it over to him, I want to start off with a few housekeeping items. So first of all, today's webinar is 90 minutes and we have 3 great presenters, and then we'll do a question and answer session. So there's 2 ways you can ask questions. Anytime throughout the webinar, you can type your question in the question box. You can see on our slide here, it shows you where that is. And we can keep track of those for the end of the Q&A session. You can also raise your hand during the Q&A part of the webinar, and I'll try to call on people if the connections are good enough so you can ask your questions directly using that small hand icon on the toolbar to the left of your name. So if you're having any technical difficulties during the webinar, such as trouble hearing or seeing whatever, please send us a message via that question box and we'll try to resolve that issue. So what I'll do now is hand it over to my co-host, Gabriel Grimstitch, and enjoy the webinar today.
Thank you, Petra, and hi everybody. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for tuning in. My name is Gabriel Grimstitch. I work with the United Nations Environment Program in the Marine and Coastal Ecosystems Unit, and I'm based here in Nairobi in Kenya. And it's my pleasure to welcome you to the webinar co-hosted by the Reef Resilience Network and by UNEP. So thank you, Petra McGowan. It's a real pleasure to be here. And this webinar is on seagrass ecosystems. Now, seagrass ecosystems are coastal super ecosystems. They are critical habitats found around the world, very widespread coastal ecosystems. I'm sure you've come across them. They're found in at least 159 countries on 6 continents. And they are fascinating because they're flowering plants that actually descended from a common ancestor on land. So they're plants that are found in the ocean now, but in the past, their ancestors were terrestrial and they moved back to the ocean. So it's really, I always found that super interesting. And also what's very interesting about them is that we don't know where they all are. So we've mapped about 300,000 kilometers squared of seagrass around the world, but we don't know where all the seagrass is. And once in a while, new seagrass meadows and new seagrass patches are found in different countries. So it's really an exciting area of study as well. Now, despite how interesting and how valuable and how fascinating they are, seagrasses really don't get the same attention that some of their more colorful or their more grandiose neighbors get, the coral reefs and the mangroves. Yet at UNEP, we really value the importance of seagrass. We really think it's a critical ecosystem that we want to protect and that should be valued and should receive similar attention. So to this end, we developed a global report called Out of the Blue, which was released in June 2020 on World Oceans Day. And this report, which I hope you've seen, highlights the importance of seagrass to people and to biodiversity. And it highlights several important and critical ecosystem services. The first is food security. So it may surprise you to know that at least 20% of the world's major fisheries depend on healthy seagrass ecosystems. So seagrass helps to put fish on our plates. It helps to feed us. Number 2, carbon sequestration. So seagrass may only cover about 0.1% of the ocean floor. As we know, the ocean is vast, but it contains about 18% of the world's oceanic or marine carbon. So despite their small area, relatively small area, seagrass can be a very intense carbon sink. Number 3, it protects our coasts. So it stops the energy from storms, it stops flooding, it stops erosion, and it can save lives. Number 4, it has very high cultural value to many communities. So the lives of people are often intertwined with the seagrass ecosystems around them if they live next to them. And healthy seagrasses can be good for, beneficial for healthy people. Number 5, biodiversity and endangered or charismatic species. So turtles, seahorses, dugongs are found in seagrass ecosystems. And number 6, the connectivity to adjacent ecosystems. So coral reefs and mangroves are often found next to seagrasses, and there's a lot of connectivity, a lot of movement of species, a lot of movement of sediment between these ecosystems. So a healthy seagrass can be useful or can be beneficial for a healthy mangrove or a healthy coral reef. However, unfortunately, like so many ecosystems around the world, it is in decline, and mostly due to anthropogenic or human activity. It's being lost at an unprecedented rate. We've lost approximately 30% of seagrass ecosystems since the 1930s. And the vast majority is unprotected outside marine protected areas. And even if they are within marine protected areas, these MPAs are not always fully managed, or and certainly not in the context of seagrass. So there's a challenge for us to protect our seagrass so that it can protect us. But we need new and innovative approaches to do so, to protect the seagrass and to realize its value. So this approach, or this theory of payment for ecosystem services, which we will be discussing today, it's in its infancy when it comes to coastal ecosystems. There's been some work on mangroves and coral reefs, but not a lot on seagrass. And we define payment for ecosystem services as a mechanism for environmental protection through which individuals or organizations pay managers or stewards to carry out activities that preserve or enhance the provision of ecosystem services, sometimes to make up for damaging activities. So, for example, the carbon market is a payment for ecosystem services scheme, where an organization can protect let's say a seagrass bed or a mangrove forest because they absorb carbon from the atmosphere and they sink it and they store it. And in doing so, you offset some of the carbon emissions from your organization or your individual's life. Now, UNEP is collaborating with the Kenya Marine and Fisheries Research Institute, KEMFRI, with the Edinburgh Napier University, and with the Association for Coastal Ecosystem Services to produce a manual for payment for ecosystem services for seagrass ecosystems and for communities that live around seagrass. So this new innovative approach, we want to provide some guidance for that. And this guidance is mostly based on our experience in Kenya, here on the coast, where we've been working with KEMFRI and with Edinburgh Napier University to develop a pilot project for seagrass and carbon in Gazi Bay, which is Gazi is a community in the southern Kenyan coast, Kwale County, which is famous, I think, now around the world because of its innovative and groundbreaking work on mangrove carbon with a project called Mikoko Pamoja, which we'll hear more about today. And now the idea is to extend this work to seagrass, and I'll let my fellow speakers talk more about that. I also just want to highlight that this manual that we've produced and which is now available is also in French, Spanish, as well as in English. So, available for communities around the world. And without further ado, I will pass over to the next speaker, who is Professor Mark Huxham from the University of Edinburgh Napier. Thank you.
Hello, everyone. I'm hoping you can hear me. Thank you very much for that introduction, Gabriel. And as Gabriel said, I'm based at Edinburgh Napier University up here in Scotland. I'm going to talk a little bit about some of the work that we've been doing, in fact, for over the last 2 decades now in southern Kenya, with a large range of colleagues and collaborators, but particularly including Kenya Marine and Fisheries Research Institute and the charity Association for Coastal Ecosystems. So I want to talk about the scientific foundation for using carbon as a payments for ecosystem services approach to funding seagrass conservation. So Gabriel's mentioned already that we know that seagrasses are a very important ecosystem. He talked about fisheries, and yes, around 20%, we think, of the major global fisheries are dependent in part or totally on seagrasses. But in fact, that probably underestimates seagrass importance to fisheries, because they're also a really critical support for artisanal fisheries, which don't get into those figures. They're really important for stabilizing sediment and protecting the shoreline. And in some research that we've recently done, looking at seagrasses across the globe, we found a 31 millimeter per year difference in sedimentation rates between seagrass beds and areas without seagrass. So that's really a major effect of seagrass. And then finally, they're also very important for carbon sequestration and storage, and that's the ecosystem service that we're going to discuss today. Not, I think, because it's the only or the most important ecosystem service, but because it's the one that we have expertise in Mikoko Pamoja, and also because there is a global market that exists for carbon, and that means that if we're working in conservation, we can potentially tap into that market for funding. So here's a picture of the seagrass beds in Ghazi, some of the seagrass beds. As you can see, they're growing right next to the MACT. Much of the carbon that we find in the seagrass comes from other ecosystems, particularly the mangroves. Around 50% at this site is coming out of the mangroves and being stored and captured in the seagrass beds. So seagrasses do contain large amounts of carbon. To give you a feeling for that, here's a figure taken from Forquer et al., which compares 5 global habitats for the amount of carbon that they store. So this is carbon stored per hectare. And you can see mangroves are by far the most important there in terms of the amount they store. But seagrasses, perhaps surprisingly, rival terrestrial forests in the amount of carbon they store. And unlike terrestrial forests, they're storing all of that carbon below ground. Really, the above ground plant material that you see is mostly ephemeral. Much of it is eaten on an annual basis. So where the action is below ground, so it's soil carbon. And the other thing that I want you to notice about that figure is just the huge variation in the carbon that's stored. So the average figure there is 166 tons per hectare of carbon, but some of these seagrass beds, particularly Posidonia beds in the Mediterranean, are storing huge amounts of carbon, 800 tons or more per hectare. Equally, some seagrass beds, for example, some of those here in Scotland might only be storing 30 tons of carbon or less. So there's lots of carbon, but there's a lot of variation in the amount of carbon as well. So if we want to establish a payments for ecosystem services scheme that brings money and finance and support for seagrass conservation, what do we need to do? Well, there are some basic assumptions or requirements that we need to establish. First of all, we must be able to show that there really are carbon stocks in the ecosystem and that they're going to be sufficient. Of course, all ecosystems contain carbon, so we're looking for those ecosystems which are exceptionally good, have exceptionally high carbon concentrations. Secondly, there must be some kind of realistic threat to the habitat. If we're going to ask people to pay for conservation, we must be able to show that the habitat is under threat, and that not just that it's under threat, but that this threat would lead to a loss of carbon. Thirdly, we must be able to demonstrate that the project is additional, and what that means is that if we took no action, if our project did not go ahead, then we would lose the carbon, and that nobody else is going to come along and conserve the habitat and save the carbon. And finally, we must try and avoid leakage, which is simply the displacement of damaging activities away from the protected area and to somewhere else. So those are the things we need to establish. How about the conditions in our site? Well, Gabriel gave a brief introduction to Ghazi. It's in southern Kenya, and it's an area of around 600 hectares of mangroves. There's more than double the amount of seagrass in the bay, and there's a beautiful coral reef. So it's a fantastic tropical marine seascape. close to the bay is, well, 2 villages that have more than 5,000 people living in them. And those people are very heavily dependent on the ecosystems, particularly the marine ecosystems, on their doorstep. So, for example, around 76% of people in that village rely on fuel wood, much of it coming from the mangroves to cook. And about 22% of the population are directly supported by fishing, but more than twice that are supported indirectly by fishing. So it's a tropical community that relies very heavily on marine resources. Working there now since for the last 7 years, we've been conserving mangroves and replanting mangroves and using the carbon market, the voluntary carbon market, to raise finance to help us do that. And this is an example of a carbon credit. It's issued by the accrediting body with which we're registered. That's Plan Vivo. They're a charity here in Scotland. And by going through their accreditation process, we're able to issue these credits every year and then sell them to buyers on the voluntary market. And that's how we can raise some money. And we've sold more than 10,000 of these credits now over the years, raising money for mangrove conservation and community development. So what we wanted to do was to see how we could use this model to help with seagrass conservation. After all, as I said, the seagrasses, not only are they very important, but they're also closely ecologically linked with the mangroves. So what are the prospects for seagrass conservation and pests on this site? Well, first of all, I said we need to show that there's carbon, and there's clear enhancement of sediment carbon by the seagrass here. These are some results taken from a PhD student who worked on the site, Michael Njoroge, and he was looking at the 4 common dominant species of seagrass on this site. And what these lines show are cores. We're going from the surface up here down to 50 centimeters depth below the sediment surface. And this is the amount of carbon in those cores. And in each case, for each of these species, you can see there's a clear non-vegetated area, a control area, if you like, compared with a seagrass area. And in every case, there's very significant enhancement of carbon in the sediment. And what's really interesting is that significant enhancement continues to depth, which tells us that the effects of seagrass must be there for a long time. We don't quite know how old sediment down here at 50 centimeters depth is, but it will certainly be decades to centuries, possibly many centuries. So seagrass definitely enhances carbon storage. We know that that can be for a long time. And in fact, the mean sediment carbon here is about 236 tons per hectare, which is 60 tons per hectare higher than the global average. So these are pretty powerful carbon stores, these tropical seagrasses. I said we need to show that the habitat is at risk. Gabriel mentioned on a global level that we're losing seagrass. In fact, we're losing it at a very fast rate, according to some estimates of up to 7% per year. In Kenya, we were able to use satellite information to look at the amounts of seagrass that we've lost over the last 30 years or so. And what we find was that rates of loss are accelerating, and that we're now losing about 1.8% of seagrass per year. So roughly we'll lose about half of the remaining seagrass in the next 30 years. So there's quite a significant rate of loss going on. We're not quite sure what the causes of that loss are, but anecdotally, and using, for example, scars that we can see in those satellite images, it looks like fishing activities, boating activities are a very important cause of loss. So there's plenty of carbon in seagrass. We're losing seagrass. What's the implication of that seagrass loss for the carbon that's stored below ground? Well, this figure here shows a the results of an experiment that we ran recently in Ghazi Bay. This was a very small scale removal experiment. So we basically went and mowed the seagrass beds. We cut them off artificially. And we persisted with that for quite some time. And very, very interestingly, what happens when you do that is that you change the biology of those patches of seagrass. So you go from heavily vegetated marine patches, which are the dark green areas here, and they tend to be dominated by these kinds of organisms, small mollusks, amphipods, smaller worms. And you go to open, clear, sandy areas, which tend to be dominated by these organisms, burrowing fish and burrowing shrimps. And these organisms are bioturbators. That means they actively burrow into the sediment and push up sediment that is buried onto the surface. And what that means is that they're actively facilitating the oxidation of this stored carbon. So we rapidly lose carbon from these sites, and in 1 year we lost around 16 tons of carbon per hectare from these experimental sites. So we've got very direct experimental evidence that the carbon certainly is at risk if the seagrass is lost. So what are the opportunities for management at this site? Well, we think that fishing is an important cause of seagrass loss here. And at Ghazi, most of the fishing is non-destructive. So most of it occurs by hand collection and using basket traps. A relatively small amount of the fishing occurs using things like nets, and it's the nets, people dragging seine nets and other kinds of netting, which is damaging to the seagrass. So in fact, this is good news, because it means that we need to compensate or intervene over a relatively small amount of activity in the bay. And so we could, using pests, we could raise relatively modest amounts of sums and potentially compensate those people whom we'd have to displace and ask to stop using their netting activities. So in conclusion, what are the opportunities for payments for ecosystem services to support seagrass? Well, we know that seagrass loss leads to carbon loss. We know that business as usual will result in further losses of seagrass, and there's a potential for management intervention here, particularly the control of destructive fishing activities. There are challenges, however, in implementing a carbon-based pest project at this site. We've only got about 18% of the carbon density that we find in mangroves, although mangroves are exceptionally carbon dense ecosystems. The technical background, it's quite complex to do this, and in order to intervene, we're going to have to involve multiple stakeholders. There are lots and lots of people using the bay there, lots of fishermen, both local fishers and international fishers, as well as other people with a stake there. So management interventions could be complex. So I'm going to hand over now to my colleague, Robyn Shilland, and Robyn is going to talk a little bit more depth about the management and regulatory challenges in establishing seagrass pests.
We're just changing presenters, and I'm sure Robyn will be on in a second, so hang on with us.
Oh, is that my screen sorted now? Okay.
It says I'm waiting to see it, Robyn.
Ah, it's telling me that it's sharing, so perhaps it's taking a while to come through.
Okay. Here we go. There you go.
Exactly. Great. Great. Hello, everybody. My name's Robyn. I work for the Association for Coastal Ecosystem Services, or ACES, which is a UK-based charity that supports community-led blue carbon projects in Kenya that Mark has just spoken about. And I'm also a research assistant with Mark at Edinburgh Napier University, kind of researching the ethics of the carbon market, and especially kind of analysing buyers of blue carbon credits and kind of what drives them to offset with blue carbon. So Mark has discussed kind of the science of seagrass carbon and some of the opportunities that carbon trading can offer community groups in conserving seagrass meadows. I'm going to build on what he picked up on there at the end with challenges in running these projects and kind of discuss some of the things that project developers will have to take into consideration in project design. So I'll be discussing these challenges primarily in the context of requirements for certification under carbon standards. So for anybody who isn't familiar with carbon standards, they are a set of criteria and methodologies that are administered by a certifying body that projects must meet in order to be able to trade carbon. So for example, Mikoko Pamoja, which Mark has discussed and Anne will discuss after me, is certified by Plan Vivo under the Plan Vivo standard. So firstly, project developers have to consider how they will finance their project. And that's both kind of in the initial project design and launch stages, which are quite kind of labour and finance intensive, and also in the long term, once you've got accreditation and you're up and running and trading carbon credits. So carbon income comes quite late in the process. So you need to achieve certification under one of these carbon standards. You need independent validation, and in some cases you need a year of operations before you can even start to begin trading carbon credits and getting that income. So especially for that kind of initial stage, you need to source kind of external finances, and that could come from grants or philanthropy or from private investment. Project developers also need to consider the income that they can reasonably expect to get from seagrass carbon. Seagrass sequesters around a fifth to a quarter of the carbon the mangroves do on average. So that's quite a broad figure, as Mark said. Both mangrove and seagrass carbon can vary quite a bit globally. But that means, on average, you're only going to get around about a quarter of the income per hectare or per unit area that you would get from mangrove carbon trading. So that kind of income, the income from carbon finance, might not be a kind of viable level of finance to support your project on its own, kind of in the long term. And on top of those costs, once you're established on the carbon market and you have your certification and your validation and you're trading carbon credits, it's well, for us at least, it's a fairly sustainable source of income, but it is kind of subject to fluctuation in the carbon market according to demand for offsetting. So that can be led by things like the crisis that we're in at the moment. There's been something like an 80% drop in flights, at least at the height of lockdown, which means it's fantastic, there's lower emissions, but it also means that these projects that rely on carbon income are very suddenly plunged into a situation where they have to find alternative sources of income. It's sensible to kind of keep diverse sources of income or keep an eye on kind of alternatives to carbon income alongside the trading of carbon. As well as things like this crisis, the carbon market is also kind of subject to change under sort of changing policy horizons. So things like the NDCs, which are in their second round of submissions now, and things like Article 6 of the Paris Agreement, which is currently being finalised, can all kind of impact on how the carbon market functions. So in addition to this, the requirements of certifying seagrass under these carbon standards are quite technically demanding. So the only certifiable carbon in seagrass habitats is in the soil. So in other habitats, including mangroves, the actual biomass of the plant itself, so the what you see above ground and also the roots, that can be certified and is kind of technically more feasible to assess and to monitor. With seagrass, the biomass is fairly negligible compared to the soil carbon, And it's also more difficult to prove that the carbon that's in the biomass will be sequestered on a long-term basis. So you're really reliant on the soil carbon. So assessing soil carbon requires taking sediment cores and also needs access to lab facilities where you can kind of analyze the carbon within those cores. So that may be challenging or even impossible for communities who don't have access to these facilities. Physically, seagrass habitats, being intertidal or subtidal, are quite challenging to access. So this increases the challenges of surveying and monitoring. So exactly what survey methods will be used will depend on the carbon standard that you decide to follow. But what we're doing and what other groups can do is look at kind of established citizen science protocols like Seagrass Watch, which are accessible to a wide range of users and also kind of sufficiently robust to at least kind of base a monitoring program on. One of the main challenges of certification under seagrass standards are the uncertainties that still exist in seagrass science and the implications that these uncertainties have for the ability of the project to meet carbon standard requirements. So under these carbon standards, projects are required to demonstrate kind of a number of principles and criteria surrounding where the carbon comes from, how and where it is stored in the seagrass ecosystem, and what happens to it if the meadow is disturbed or destroyed. So one of the key concepts is additionality. So this is the principle that projects can kind of prove that their activities are additional to what would have occurred kind of in the absence of the project. So this can be at a policy or management level. So kind of looking at what laws and policies are in place that prevent or discourage damaging activities, but also in the context of soil carbon. So proving that seagrass habitat is indeed capturing carbon that would not otherwise have been sequestered. So one thing project developers need to look at here is the difference between allochthonous and autochthonous carbon, which kind of refers to where the carbon originated. So autochthonous carbon was generated by the seagrass itself. So photosynthesis captures the carbon dioxide, and then it's turned into organic carbon and stored. But allochthonous carbon is carbon that originated outside of the seagrass ecosystem, but is stored in the seagrass. So things like organic carbon can flow down rivers and estuaries, or from kind of adjacent mangrove forests. So there's kind of uncertainty regarding what would happen to that allochthonous carbon if the seagrass meadows weren't there to capture it. So this allochthonous carbon might not actually be eligible to count as seagrass carbon if it can't actually be proven that the seagrass is preventing the remineralization of that allochthonous carbon into CO2. So there's a big challenge in addressing where seagrass soil comes from, and to address this challenge, VCS, which is the Verified Carbon Standard, which is currently the only carbon standard to have methodologies for seagrass carbon, takes quite conservative assumptions about how much of the carbon in the seagrass ecosystem is allochthonous. So you kind of have to make a large deduction from the carbon that you have in your seagrass meadow. A second issue is permanence. So Mark touched on this as well, kind of looking at what depth is seagrass sequestered on a long enough timescale to be eligible for carbon trading. So generally under carbon standards, this is assumed as at 100 years. And also looking at kind of what happens to the seagrass carbon if the meadow is either disturbed or destroyed. So again, if the seagrass, the carbon kind of simply flows out into the sea and is stored in deep sea muds, you can't necessarily claim that seagrass is having that kind of net carbon impact, carbon benefit. And thirdly, as in any carbon trading project, and again, as Mark mentioned, you have to look at leakage. So kind of looking at the risk that by protecting one area, harmful activities might just simply shift elsewhere, kind of leading to no net carbon benefit. So this can be addressed under carbon standards through kind of reasonable assumptions and also by measures taken to prevent this shift, which Anne will touch on after me. And this may need to be monitored and reported periodically throughout the project lifespan. So basically, while seagrasses are kind of popular as these kind of fantastic blue carbon ecosystems, and they like as Gabriel said in his introduction, they store carbon, they protect coasts, they enhance fisheries, they enhance biodiversity. When it actually comes to certifying, at least under carbon, things kind of get a bit more complex in terms of demonstrating the carbon dynamics within the ecosystem, and where evidence can't be presented, the kind of default position of carbon standards tends to be to make conservative assumptions and detract from the carbon that you can claim. So these are the challenges that are quite carbon specific, particularly relating to the requirements of the carbon standards. The community manual that Gabriel presented at the start also kind of includes more considerations that project developers will need to take into account that are kind of common to any community-based management project. So things like looking at how the project engages with communities and stakeholders, and looking at benefit sharing within these groups. Looking at kind of governance systems, making sure that it's both locally and nationally appropriate, and also represents the communities kind of within the project area. And considering kind of legal rights to govern, to make sure that projects are not only enforceable, but also fair and sustainable. So the carbon standards, particularly those in the voluntary market, which kind of caters to these smaller community-led projects protecting natural ecosystems, they tend to embed these principles. So actually achieving certification means that you need to not only tick the carbon boxes and science boxes, but also the kind of social side of things, and make sure that your project is socially appropriate. So lastly, I just wanted to highlight that given the kind of considerable challenges of seagrass carbon, certification bodies do offer alternatives to certifying carbon as an ecosystem service. So projects can be certified against alternative ecosystem services, things like coastal protection and fisheries enhancement that we've talked about. So Vera, who administer the VCS, the Verified Carbon Standard, they have a couple of other standards. They have the SDG Vista, which accredits projects against the Sustainable Development Goals, or SDGs, and also another called Climate, Communities and Biodiversity, which kind of includes those three aspects into the certification. Plan Vivo, who our project is certified with, they also have the option to accredit against other ecosystem services, kind of other than carbon, under the Plan Vivo standard. However, although these options exist, there's kind of been limited to no uptake of them, at least in blue carbon ecosystems. A couple of reasons for this, partly because there's the main established market is for carbon. Carbon's relatively popular at the moment, and carbon offsetting, at least until the COVID crisis, was kind of on the rise, and then the market was strong. Whereas for other ecosystem services, there's not necessarily those kind of established markets, and you might need to put more work into kind of finding your buyers if you're going to sell credits for things like, example, coastal protection. And in addition to the markets challenge, methodologies for accreditation against these ecosystem services are also lacking. So projects would have to kind of put a lot of work into not only establishing their own project, but creating methodologies that would be accepted by the carbon standards. So these challenges, as well as kind of the opportunities that Mark presented and the case study that Anne is about to present, are all explored in the community guide. So we created this with kind of accessibility in mind. So the purpose was to kind of take a lot of the technical literature that's out there, and also our personal experiences of running blue carbon mangrove projects in Kenya, and create a document that's accessible for community groups. So we assume that they're not experts, but they may have some knowledge of science or management. yeah, accessibility was kind of key in the target for that document. It's not supposed to be a kind of step-by-step how-to guide, kind of recognizing that projects are unique and might follow their own paths and their own methodologies and so on, but more of a kind of signposting document that project developers can take and kind of use to guide their journey in creating these projects. And it largely draws on our collective experience of operating a blue carbon project, Mikoko Pamoja in Kenya, which Anne, who is just about to present, will speak more about. Thank you.
Oh, Anne, you're muted, I think.
Okay. Hello, everyone. My name is Wanjiru. I'm the Social Impact Officer on Mikoko Pamoja project, which is an initiative of the Kenya Marine and Fisheries Research Institute in collaboration with the Edinburgh Napier University and Bangor in the UK. So my colleagues have talked up, my colleagues Robyn and Mark have already touched on Mikoko Pamoja. So I'm going to talk a little bit more about our activities in relation to mangrove conservation, the impact the project is creating in the community, and also our seagrass related activities. So Mikoko Pamoja is a Swahili word which means mangrove together, and it's the first project in the world to conserve mangroves through the sale of carbon credits. The project is community-led in that it is managed by a committee of 13 people who are democratically elected from the community after every 2 years, and they are assisted by a project coordinator. So the project has been verified by Plan Vivo standards to run for 20 years, and where we have been selling a total of 2,500 tons of carbon credits from 2013. So it has been going on for about 7 years now. So we have a fixed benefit sharing structure where the Association for Coastal Ecosystem Service, which is a Scottish charity organization, helps us in marketing our carbon credits. Once they have sold the credit, then they retain 6%, and this amount is used after every 5 years to pay for a validator, an external validator who comes to the project to ensure that, or to look at what we've been doing and what we've been reporting, whether it's actually true. So they're there to verify. So the rest of the money is transferred into our community or our project account, and where 32% it goes towards community development project. I'll be talking more about these projects that have been implemented. And then we have 36% that goes towards mangrove restoration activities, paying for community scouts who are there to do surveillance in the project areas to ensure that there's no illegal harvesting. And then we have 21% that pays for the project coordinator's salary, and 5% that covers office expenses. So in the 7 years the project has been in operation, we've created impact in the community in several ways. One of the ways that is through education, where we've bought books, more than 600 books for the 2 local schools in the project area. So the project covers 2 villages, which is Makongeni and Gazi villages. So we bought books. Apart from books, we've bought desks for one of the schools and also renovated classrooms that were previously leaking. In terms of water, we've installed fresh water in the community because of the location of the village near the ocean. You'll find that most of the water points are salty. So we created water points where the community can be able to access water at affordable prices. And also, we also installed water in the 2 schools, which have a total of more than 1,000 students. So now they can enjoy fresh drinking water. And also we bought a water tank for the high school that is in one of the village. So apart from that, we created jobs by employing 2 project coordinators and 2 forest scouts. And also we are contributing to mangrove reforestation by planting mangroves in the degraded shorelines of Gazi Bay. So apart from that, Mikoko Pamoja has influenced the creation or the replication of another project in Vanga, which is further south near the Kenya-Tanzania border. This project is 4 times bigger than Mikoko Pamoja, and it's conserving 460 hectares of mangroves. It has also been verified by Plant Vivo Systems and Standards to sell over 6,000 tons of carbon in the voluntary carbon market for 20 years. But for this project, it's covering 3 villages, so it's much bigger. Okay, so we have ongoing plans in such that through assistance from students, we've been able to research and design efficient fuel stocks, which are bringing benefits to the community in terms of carbon savings as well as health benefits. Apart from that, we are working to develop the world's first seagrass conservation project to be funded by carbon credits, and I'll be talking more about it. And then we also seek to establish a local managed marine area that incorporates seagrass. So as far as incorporating seagrass into mangrove conservation, last year we had a consultative meeting with the stakeholders from the community who are mostly fishermen, and they're representing the beach management unit, which is BMU. So in this meeting, our aim was, first of all, to present on past seagrass research that has been conducted in Gazi Bay, and then to introduce them to the concept of payment for ecosystem service, because coming from Gazi, they are mostly familiar with the mangrove payment for ecosystem service concept. So we also wanted to map other activities that are happening within the bay, within the seagrass meadows, and also ensure that there's community support. Because without this community support, then the project is doomed to fail. And we've seen that through Mikoko Pamoja, where we've received immense support from the community. So we had a total of 31 participants from the community, from government institutions, and from Mikoko Pamoja. So, so far we have 3 project areas that have been proposed that will carry out the activities. And these project areas were chosen on the basis of carbon content. That is, they showed that there's sufficient carbon content in the areas, and then they are accessible by the community, which is important because the community are the ones who will be doing monitoring. And then there was species abundance, and also they demonstrated degradation. There was degradation of seagrass in the areas. So right now we are not at the beginning of the project. It's important to note that actually we've gone through several milestones. We've gone through, the first milestone that we've gone through is accreditation, where we've been formally approved by Plan Vivo to continue with the project using the Carbon Plus model. And then the second milestone is finance. Robyn has talked about it. That can be a challenge. So right now we are approaching buyers who purchase Mikoko Pamoja credits, and we're asking them whether they're interested and willing to pay a surplus of about $2 per credit to receive a Carbon Plus benefit of contributing to seagrass conservation. And so far we've seen interest from them. to purchase the credits, and so we are confident that there is a market for this credit. So right now we are at the final stage, which is implementation, which involves holding meetings with the community. And we've already appraised them on the project. We've already told them about what this project is all about, and we've also sought their support. So the next thing that we want to do is to agree on a benefit sharing structure, just like what we have in Mikoko Pamoja, and also demarcate the project areas together with the stakeholders. So for more information on our project, or for those who are interested in purchasing these credits, they can access the SS website that is provided there. Thank you very much.
Thank you, Anne, and thank you all the presenters. I'm going to invite people back on to join for the question and answer. And I'll start. There's two ways, remember, you can ask questions. You can raise your hand using the little hand icon, or I already have questions coming through the question box. So I'm going to start there, and I'll look for hands raised as well. I'm inviting Robyn and Mark and Anne back. You can turn your cameras on, and Gabriel, and I'll start doing the questions. So the first question is clarification, I think on one of your slides, Anne. ACES returned 6% or 94% of the sold credits to the community group.
Okay, so I mentioned that ACES, which is the Scottish charity organization that is responsible or assists us in marketing our credits, it retains 6%. So because after every 5 years, we are supposed to have an external validator who comes in to look at what we've been doing and verify whether what we've been reporting in our annual work plans is true. So every year we submit an annual work plan showing that our activity, what we've done throughout the year. So after 5 years, they come and they verify. They go to the community and they ask, has this project been implemented? They go to the forest and they look at whether there's degradation. So this 6% that is retained in the account is what is used to fund for his visit.
Great, thanks. Another question is, are advance credits given to the project in order to generate revenue to fund the startup activities? I don't know who's best to answer.
To Robyn.
Okay, Robyn.
Just unmuting myself. So you can follow different models of accreditation. Some projects you can kind of accredit kind of in the past. So you can you get your certification, but you can kind of have a project start date in the past. So at that point you can get like several years of credits at that point. But no, generally you need that finance up front to be able to set up a project. So if anybody's kind of interested in establishing one of these projects, I'd say there's not to kind of underestimate the costs or the time that it'll take to set up that project, and kind of seek kind of additional funding to cover those upfront costs.
Robyn, as a follow-up, do you have estimates of startup costs for our listeners? Like, what should they be thinking a startup of this kind of work takes?
Sure. I'll pass that to Mark if that's okay. Mark was heavily involved in the startup of Mikoko Pamoja, so he can probably answer that in more detail than I can.
Sure, thanks, Robyn. It's quite a tricky thing to estimate because so much of our costs were in kind for Mikoko Pamoja, and that's because we were quite heavily reliant on students and on volunteers to do some of the basic science that we needed. However, for mangroves, well, we've done that science now. So the way that these carbon projects work is that if there's credible information that you can take from other sites, that usually allows you to use those default values, for example, for average carbon stocks. Because mangroves were new, we had to do that work mostly for ourselves. So my estimate of the startup cost for Mikoko Pamoja were about 280,000 UK pounds. It would be less, it would be significantly less now. However, the startup costs for seagrass, we're in a similar situation as we were for mangroves, because there's a lot of basic science that still needs to be done.
Great. Thanks for clarifying that. And so a good strategy for people might be finding partners to help front those startup costs, or partnerships with universities like you guys have done. Okay.
Yes, absolutely. And if you can get, there's a lot of scientific interest in this, so you might be able to get funding in kind from people coming and doing their research with you.
Great. Okay, another question. I think this was early on during, Mark, your presentation. The comment is carbon stocks must be sufficient. So until which amount of carbon is sufficient to be potential to PES schemes?
So there's no simple answer to that. It depends on the scope, particularly the spatial scope of your scheme. So for example, some carbon pest schemes use grasslands as their ecosystem. Grasslands have much lower carbon in them than, well, seagrass and particularly mangroves. However, if you've got a big enough grassland, like in Mongolia, and you can convince people, you can have a project that will help store carbon in that grassland, then you can use it. So the trade-off is that the more carbon dense your habitat, the less of that habitat you're going to need to manage and conserve in order to make it financially viable.
Okay. This question came in, I think, before Anne presented, but I want to just make sure you guys can clarify for the audience. It says, Robyn and Mark, are you including the seagrass work as part of the Mikoko Pamoja Plan Vivo project as a different technical specification, or are you preparing a different project to get certified?
So I'll come back, and Robyn, feel free to follow up. But the approach at the moment is to include it in our current technical specification for Mikoko Pamoja, and that's partly around resources, but it's mainly because of the barriers and challenges that we've discussed in obtaining independent carbon credits that are credited solely for seagrass. And that's why we've gone for this carbon plus model. So we have a range of buyers and stakeholders who know Mikoko Pamoja well, and who are familiar with the kinds of quality assurance processes that we have for the mangrove credits. And as Anne explained, some of those buyers are interested in supporting seagrass conservation. So they're interested in adding a supplement that will be, if you like, a carbon plus benefit. And the way so that is accredited in the sense that the technical spec for Plan Vivo now includes it, and we will be reporting on that seagrass work every year. However, what we won't be reporting on is we won't be required to go and measure carbon stocks every year in the seagrass beds, because to do that would be, well, is very expensive to do that every year, and beyond the scope of Mikoko Pamoja. So we're hoping that this hybrid model will provide a mechanism for linking carbon conservation to seagrass conservation. I think in the future, we will test the market, as it were, and in the future there's certainly prospects for independently accredited seagrass projects.
Thanks, Mark. Okay, here's a longer one. I feel like almost I should call on Phil, but Phil, chime in if I don't get this right. It's asking about familiarity with the scheme in the Yucatan region of Mexico to ensure a section of the Mesoamerican barrier reef against storm damage. with insurance premiums paid by hotel operators who benefit from the ecosystem services provided by the reef. Has there been thought of applying a similar scheme to seagrass and mangroves? Another case where there's private sector interests who might benefit from those services.
Robyn, do you want to come in first? And I think you're muted.
Muted, Robyn.
Sure. Yeah, personally, I'm not overly familiar with the case that Phil mentioned. I think it's a very good point about kind of when you're looking at the alternative markets, or the markets for alternative ecosystem services, to look for those buyers or those funders, those investors who have a vested interest in that ecosystem service. So things like insurance companies for coastal protection is a great example. I think I've never been, well, I'm not aware of anywhere where it's been kind of explicitly linked, as in where they've valued the service as a coastal protection of say mangroves or seagrass, translated that into credits and then sold those credits. But certainly, I think as well for kind of startup funding, things like insurance companies might be kind of sensible organizations to go for that. Or, I mean, not necessarily just insurance companies, but anybody with that kind of vested interest in the benefits that that ecosystem service provides. I don't know if Mark has anything to add to that.
Yes, just two things. There are also a number of schemes that I'm aware of, particularly in Indonesia, that use payments from visiting eco-tourists to help conserve, well, seagrass and reef systems. So I think it certainly can work as a model. We in Gazi and along the Kenyan coast in general, the biggest theoretical benefit ecosystem service of mangroves is coastal protection. So you can do the sums economically, and you find that there's a massive value of having mangroves there. The challenge that we found was that there was nobody willing to pay for that theoretical value, and that's why in the end we went with carbon for the mangroves. So I guess the opportunities to tap into that kind of market will all depend on the site that you're working in, and how, I guess, whether there are wealthy people near the site who are going to be willing to pay that.
All right. Two questions here. Who establishes the total number of credits per project site, and who manages the credit ledger per site? I'm not sure who's best to answer.
Do you want to take that one, Mark?
Sure, yeah. So the total credits are essentially, one credit is 1 ton of CO2 equivalent, and that's determined by the size of your project. So, and the science of your project. So that's up to the project design, and of course and that comes back to this issue of spatial scale. The bigger your project, the more credits you're likely to be able to sell. But of course, that also increases the expense and the challenge of administering the project. In terms of who administers the project, the credits, the way it works is that they're formally issued by the accrediting body, in our case, Plan Vivo. So as Robyn was explaining, we issue our credits post hoc, which means we demonstrate that we've sequestered a certain amount of carbon over a particular calendar year. Once the accrediting body has confirmed that that's the case, when they've looked at our annual reports, those credits are then issued, and when they're sold, they're retired on an international brokerage, which is the market site. So there's a kind of transparent store for all of those credits, and that's to prevent people selling credits twice.
Okay, we have some great questions here that I think will really help people keep understanding this stuff, so I'm going to keep trying to get through them. So looking at the requirements for the pest conservation scheme, are they site specific For instance, if the proposed site is Zanzibar, do I have to establish carbon sequestration capacity for the site of interest?
So I think that comes back to my earlier comment about the kinds of carbon and the kinds of ecosystem that you're using. If you were planning a terrestrial forestry project on Zanzibar, because there are a series of well understood estimates of terrestrial carbon storage, you could probably take some of those estimates and use them at your site. On the other hand, if you were planning something quite radical like using seagrass, you would almost certainly have to you'd have to measure the carbon in your sites. So I think mangroves are an intermediate situation now. So because, well, we've done plenty of work in East Africa now, and there's good estimates of mangrove carbon in a range of East African sites, I think most project standards would accept reasonable regional estimates rather than having to measure them all from scratch. But it does depend on the standard that you go with, and as Robyn explained, there are a number of different standards.
Here's another one. Is my understanding correct that tapping into the carbon market is not possible if the seagrass is currently located within a marine protected area, despite the effectiveness?
I think that goes back to additionality, that kind of requirement for a project to demonstrate that it is having an impact kind of over and above what is kind of the status quo. So kind of on paper and on the face of it, that would be a fair assumption that if it's already protected, the protection is there, and so the project would not be additional. Obviously, I'm sure, as most people are aware, kind of protection on paper isn't always translated into protection on the ground. And so if there is kind of failures in current management, kind of regardless of what the policies or the frameworks are in place to kind of enact that legislation, then projects can demonstrate, if they can demonstrate that management is failing, then they can kind of claim carbon credits by kind of implementing these interventions and kind of having that impact on the damaging activities. So, for example, in Kenya, where our Mikoko Pamoja project is, mangroves are property of the government, and technically it's largely illegal to deforest mangroves. But in reality, on the ground, that protection just isn't realised. So no, as long as you can demonstrate, kind of, it's usually you look at kind of historic rates of degradation. You might use satellite imagery, or if it exists, kind of on the ground measurements, and demonstrate that degradation is indeed happening, regardless of any protection that's in place. Then you can establish a project.
And just to come in briefly there, following up on what Robyn said, it may actually be a benefit for you, because it may then be possible to work very closely in collaboration with the enforcement agency and say, look, this is, we're going to help you enforce this law, and what you need is a particular extra resource or some more technical capacity, whatever it is in your case. So as long as you can show that additionality empirically, then there's no reason why you can't operate in what is technically a protected area.
All right. What is the actual annual revenue generated by Mikoko Pamoja? So what is it's the 94% of what?
Sure. So we generate around about 2,000 tons per year in total. What the actual revenue is from that kind of depends on the carbon market and how strong it is. So kind of in recent years, or let's say probably in the last 2 years, while the market's been really strong, we tend to sell credits for kind of 10 to 13 US dollars per ton. which kind of comes to around 23,000 US dollars. In the early days, that was less. We sold for something like $9 a ton, and so the kind of total income was kind of correspondingly lower. And then obviously, kind of crises like this, if they hit the carbon market, and might need to drop a price to account for demand. But that's kind of the rough figures that we work with.
Thanks, Robyn. For coastal communities where it may be unrealistic to have the funding or technical expertise to go through the verification process, is a well-managed, non-verified approach a viable option to generate initial funding, or at least until practices are established enough to enter into verification?
I'll take that one. I'll kind of draw on my experience that I'm currently working on at the moment that I mentioned, working as a research assistant with Mark, kind of looking at buyer motivations. So I've been speaking to lots of buyers of Mikoko Pamoja credits, and also other project developers, including projects who run kind of unaccredited seagrass projects. I think that it's been quite interesting speaking to our own buyers. The kind of consensus seems to be that certification is very important to them. But speaking to the unaccredited projects who kind of sell, they use the same carbon offset language, but they don't follow the same accreditation structure. They seem to have a reasonable market for their credits as well, or what they bring in donations rather than selling offsets as such. So I think there seems to be kind of different markets there. I think one thing would be to be very aware of is your kind of credibility and your reputation as a project, and kind of follow as many of the principles of a carbon standard as possible, including kind of robust and also realistic science, and also the same kind of social principles that I talked about. But yes, these kind of unaccredited projects do currently exist.
All right, next question is for Anne. Anne, you have run Mikoko Pamoja for around 10 years, it says. How supportive are the people in the project area in terms of mangrove management?
Okay, we've noticed that there's several building blocks that have contributed to the success of the project. One of them is science, government support, that we are being supported by the organization that is responsible for managing forests, and also ChemFree, which is a research institute, and also now community support, because without the community, then the project is doomed to fail. So you've seen a lot of support from the community because of the benefits that they see being generated from the project. I talked about the community projects that are being implemented through the funds, through the carbon funds. So because they're seeing the practical benefits that come with mangrove conservation, then we've also seen a lot of support given by this community, and that is why this is what has influenced its replication to the other village in Banga.
Thanks, Anne. I have a couple other about Mikoko Pamoja. I'll try to group these. It says in Mikoko Pamoja, the credits are only for carbon stored in the mangroves itself and does not include soil carbon. Is that the case? If yes, are there plans to include soil carbon in coming years so that optimum utilization of the project is achieved?
I'll leave that to Mark.
Yes, our assumptions, our technical assumptions in Mikoko Pamoja are extremely conservative. So at the site, for example, we have more than 1,500 tons of carbon per hectare. I said that mangroves were extraordinarily carbon dense systems, and that's really enormous amounts of carbon. That's because we have soils that go down to more than 3 meters depth in the mangrove forests. However, we only accredit a very small proportion of that, and that's because it was, when we accredited it, it was very difficult to show technically that carbon was at risk. So we could show in the same way that we're now doing with seagrass, we could show rates of forest loss. So using satellite imagery and other methods. The question then was, well, if you lose a forest, if the forest is cut down, what happens to that stored carbon in the soil? And we didn't know, frankly, that the science wasn't there. So we made some very conservative assumptions about that. I think it would be quite nice to revisit that and sort of triple our carbon ask, and that's something that we probably want to consider in the future. Although I prefer to be conservative and cautious about this. There have been carbon projects in the past that have exaggerated their carbon benefits or just been fraudulent, and of course that doesn't do any carbon projects any good. So we're taking it cautiously, but you're right to suggest that there's a very large potential carbon stock and therefore potential carbon commodity that we don't sell at the moment.
Thanks, Mark. What are the plans to conserve the seagrass project areas with the purchase credits? Are damaged seagrass meadows being restored, or just protecting healthy seagrass meadows from damaging activities?
Maybe I'll respond to that first, and then Anne, feel free to come in. So we need to identify a management intervention that we can take that would have a positive effect. And probably globally, the biggest impact on seagrass is eutrophication. That certainly seems to be the message from the Northern European and perhaps the Australian research. However, there probably is not all that much eutrophication going on in the coastal waters of Kenya, certainly compared to European waters. And even where there is, it's really difficult to know how you can make an intervention on that, because it involves watershed interventions. But looking at the satellite imagery and also anecdotally and speaking to people, it's clear that fishing has an impact there, destructive fishing patterns. Linking to what we've just said about mangroves, in fact, most of those destructive practices are illegal in Kenya. That doesn't stop them happening. And so we think there's an opportunity here to tip the balance a little bit, to have areas where people are not doing that destructive fishing, because technically they shouldn't be doing it anyway. I think with fairly small compensation, fairly small incentive, we can remove those destructive practices from those seagrass areas, and then we will monitor recovery in the areas. So we're not planning to do any seagrass planting, partly because of the enormous expense that seagrass planting involves. Certainly there are some very interesting projects here in the UK that are doing direct restoration using planting, but they're very, very expensive. And also because I think seagrass, particularly at Ghazi, from what I know of the site, it's vigorous, and we would expect, as long as the gaps in the seagrass bed are not extensive, I would expect fairly rapid recovery.
All right. What remote sensing techniques are recommended to assess the extent of seagrass beds to generate the first baseline data and assess the extent of the beds? Any resources or recommendations for the listeners?
There's a paper that was published in 2018. It's by Harcourt et al. I'm happy to circulate that link if it's useful, which just describes what we did in the Kenyan case. It's much easier now because the images are getting much better and they're freely available. So we were using Sentinel images, and Sentinel satellite images are freely downloadable. So if you have the GIS expertise, you can use Sentinel. And in the Kenyan waters, because well, some of them are turbid, but where we found clear waters, we were finding that we could go down to 10 or 15 meters depth below tidal level. So about 30% of the seagrass that we were looking at were intertidal, and so that's fairly easy to see. You can even see it on things like Google Earth. It's the subtidal water that is more challenging, but you can find free satellite imagery that will help you with that. And there is that paper that describes some of our methods.
Great. What can be done in areas which have already lost most of their seagrasses?
Yes, that's a good question, isn't it? And I think the answer is very area specific. So I think in some areas, if you can address the causes for the seagrass loss, then seagrass can and should return quite quickly. In other areas, for example, if the sediment has been radically changed by losing the seagrass, I'm aware of some areas, for example, that become very badly eroded after seagrass loss, then it may be impossible or very difficult to restore the seagrass. So it's a very site-specific, it's very context dependent, I think, the answer to that question. But I guess the first issue is to address the causes of the loss.
Can I just add to that?
Oh, go ahead, Robyn, sorry.
Just give a plug actually to the Nature Conservancy, who I've spoken to as part of my research, looking at buyers and project developers. And actually, one of your colleagues, Petra, at the Nature Conservancy, Stephanie Simpson, who I spoke to, actually had a great conversation with her about the seagrass restoration work in the Virginia Coast Reserve. And it was really exciting to hear what's going on there. And that's totally restoration based on an area that was completely degraded. So I think it's kind of just backing up what Mark said. What they looked at was kind of the drivers of degradation. I think initially it had been oh gosh, maybe some kind of infection, I think, in the seagrass. I can't remember the details, but something had happened at kind of a significant event back in the 70s that had wiped out the seagrass meadows in the bay. And so it was a kind of combined effort of the TNC kind of working with land managers and kind of the activities going on around the bay, particularly looking at things like sedimentation. And then the actual restoration itself was involved kind of sowing of seagrass seeds, and they seem to have a lot of success with that, which is exciting.
Thanks. That actually is along the lines of a couple questions we have still in the queue. Is conservation a good measure to preserve the seagrass? But what about active restoration? Another one, why is the focus on conservation and not restoration? Can you guys address that a bit more for the audience?
Yes, I'm thinking particularly about mangroves to start with, but I think my comments are general. There's a conservation reason, and there's also a carbon reason to address that in terms of mangroves. So because they are such carbon dense habitats, and because they're so important and valuable for all of these ecosystem services we've been talking about, it just makes no sense economically or from a conservation perspective to lose these habitats. So I think our focus really should be on conserving them. That doesn't mean that we shouldn't try to restore, but something like 93% globally of the mangrove restoration attempts fail. And that's a really depressing litany, and it's caused by a number of things, but one of them is that people get paid incentives to go out and plant. They get paid incentives per hectare or even per propagule in some cases, and so they rush off and plant in inappropriate places. Now, nothing like that happens in seagrass just because there's very little seagrass restoration going on. And so I think it's really interesting scientifically to restore seagrass areas, but I think, you know, that the focus should be on conserving what we've got. Just coming back to the carbon question, if you go to a degraded site or even a fresh site and plant either seagrass or mangroves, it could take a very long time to accumulate the kinds of carbon stocks that we've been talking about. Whereas if you've got a natural site, then you already have the carbon stocks. So from a financing perspective, it's much easier to it's usually easier to justify the finance from conservation than it is from restoration. Although in Mikoko Pamoja we do both. So we do restore, we're actively replanting and restoring areas, but it contributes a tiny amount of our total carbon credits because it takes a long time for those trees to grow and accumulate carbon.
Okay, I'm going to try to fit in a couple more questions before the end. Does receiving payment for the same protected site but for different services also categorize as double accounting? For example, if you're protecting a mangrove forest and receive payments, is it possible to have additional payments for other services such as coastal protection?
Do you want to speak to that, Robyn?
I can try. I don't think I actually know the answer. It was something that I was thinking myself after kind of looking a bit more into these kind of multiple certification schemes. But no, I don't know. Do you, Mark?
I think I do. I think if the credits are specifically for one ecosystem service, for example, for carbon, then no, it's not double counting to also have a credit for another ecosystem service. I guess the complication may be for some of those innovative new kind of combined credits that you were talking about, Robyn. So if you've got credit for an SDG, for example, which involves multiple ecosystem services, then you couldn't then also market that for one of those component ecosystem services. But if you've got distinct ecosystem services, then no, that's not double counting. I don't think most. It might depend on the particular standard, but I don't think most standards would see that as double counting.
Okay, it's not clear how leakage can potentially be avoided in seagrass carbon credit projects. Any thoughts on that?
I've got some thoughts, which is it's not clear how it can be avoided in any carbon project. It's a real headache for these projects, and I've had many conversations and arguments about leakage over the years, particularly with our mangrove work, because it's so difficult because it's a counterfactual. So you have to make the argument that something isn't going to happen in the future. And of course you can't demonstrate, you can't prove it. And I'm not aware of any projects that are able to prove that leakage doesn't occur. But I think that's almost, philosophically speaking, I think it's probably impossible to do so. So our experience is that, certainly with Plan Vivo, that provided you can make a logical and sensible argument, then they will be willing to accept that. So, for example, with the mangrove work, we can calculate how many trees people were taking. We can calculate the amount of fuel wood pressure on the forest, and we can plant alternative woodlots to replace that. With the seagrass work, if we're saying to people, look, you're doing destructive fishing in these areas, that destructive fishing actually is already illegal. So you need to be a little bit cautious about that fishing, and it has a destructive impact far beyond the benefits that it brings to the community as a whole, because it's a small, as I said, it's less than 5% of all the fishing activity in the seagrass beds. So there's quite a small number of people benefiting from doing that destructive activity. It means that a fairly small alternative income to compensate those people for that activity could tip the balance there. So yes, it's true that we can't be absolutely certain that people won't just go off and you know, indulge in those activities elsewhere. But I would also make the other argument. What we've observed with the forest protected areas is that cutting outside the protected areas has gone down. In other words, there is leakage, but it's kind of positive leakage. We're having a penumbra effect around the protected area. And that's because people are just much more aware of the benefits of mangroves and the income that mangroves can bring them. So it's enhanced the awareness of conservation in the area in general.
Well, we've come to the end of the Q&A session. I'm sorry if I didn't get to your question. Here are many of the resources that we mentioned, and they can all be found on the Reef Resilience Blue Carbon pages as well. Thanks again to our presenters and my co-host, Gabriel. The recording will be sent out to the network's email list tomorrow. If you're not on our list and would like to be, email us at resilience@tnc.org. And please share the information with other practitioners that you think would be interested. When you exit the webinar, there's going to be a short survey. If you can fill it out and give us feedback on this webinar and your interest in seagrass as we explore supporting future webinars on this topic, that would be excellent. And have a great day, everyone. Thank you, guys.